Hello, chemistry. So today we're going to talk about naming and formula writing for ionic compounds. Now, remember when we talk about ionic compounds, those are things made of metals and nonmetals. Okay, and remember the bonds form always to make things stable. The ultimate goal is always stability. Ionic compounds, like I said, are made of metals and nonmetals. Remember, metals are on the left of the periodic table, nonmetals are on the right. Metals are going to lose electrons and become positively charged cations. So remember, metals are the ones that have a small amount of valence electrons and they have a low ionization energy, so they easily lose their electrons. Nonmetals will gain electrons and become negatively charged anions. Also, remember when you've been talking about ions, there are the polyatomic ions. Remember the prefix poly, just like in geometry, like a polygon is many sides. Poly means many, and atomic is atoms, particles, and ions is charged particles. So you have many atoms together that have a charge, okay? So polyatomic ions are two or more atoms that are bonded, and as a group, they have a charge. Okay, polyatomic ions are always going to stay together as a group. As a group, they're either a cation or an anion. You always want to use parentheses to show that the charge applies to the whole group. So there's some examples right here. There's also examples on your periodic table, on the back side of your periodic table. So some examples here, we have sulfate, which is SO4, and as a whole, it has a -2 charge. This 4 only goes to the oxygen, so it's 1 sulfur and 4 oxygens together that collectively have a -2 charge. We have hydroxide, which is O and an H, and together it's a negative. Nitrate is NO3, that 3 only goes to the O's, and collectively it's a -1. And ammonium, I see it got moved over, ammonium is NH4, so there's 4 H's on the end, and collectively it's a +1 charge. Okay, so let's get into the fun here. So we're talking about naming ionic compounds. Okay, it's not too tough to name them. Okay, just a couple of rules. You always name the cation first. It's always first, followed by the anion. So they always go in order: metal, then nonmetal. Remember, cations are metals, and anions are nonmetals. Okay. And then Roman numerals, you need Roman numerals for transition metals. So in a previous assignment, you already talked about how to name ions. So if we look at this example right here, K is potassium. And remember, when you name cations, you just name its name. So K is potassium. Okay. F is fluorine. Oops. But oh, wait, no. Remember when we name ions, we change the ending to IDE. Okay, so this is going to be potassium fluoride. Okay, potassium fluoride. Okay, next one, Mg. Okay, Mg is magnesium. Okay, and magnesium is just an alkaline earth metal, so you don't need any Roman numerals. It's not a transition metal. And then Cl is chloride. Okay, when you name ionic compounds, it does not matter that you have multiple of the chlorines there. Okay, chemists like yourself, right, understand that this 2 is used to balance out the charge, which we're going to talk about in formula writing coming up here. All right, CuCl, okay, Cu is copper, And copper is a transition metal, so you need a Roman numeral. And you might be going, how the heck would I figure out the Roman numeral? Okay, you look at the number over here. Okay, what's the number with chlorine? Well, you're like, there's no number written. Right, that's because it's 1. So this becomes copper 1 chloride. Okay, if you're confused on that a little bit, we'll practice some more. It'll be okay. Okay, next one, Na2SO4. Okay, it would probably be helpful if there were parentheses here. They're not required, that's why I don't have them, but it would be helpful to see. Okay, Na is sodium, and SO4 is a polyatomic ion. Okay, no need to fret, just look at the back of your periodic table, it's on there. SO4 is sulfate. Okay, is that 8 ending important? Oh, extremely important. Okay, necessary that you have that correct. Because if you screw up the ending, then you screw up what we have. If you had written down sulfide, then that would just be 1 sulfur. Or if you wrote sulfate, that's actually SO3, so it's a different compound. Okay, here's some fun stuff. Let's talk about formula writing. Okay, so a couple of things to remember when you write formulas. Compounds have no overall charge. Okay, so when you put the plus and minus together, they have to neutralize each other out completely. Okay, so the total charge from the cation cancels the total charge from the anion. And you have to write the simplest whole number ratio. Like in math class, you always simplify things. Okay, there's a nice little trick I like to call the charge flip trick, and it always works to figure out the ratio. I'll show you that. And then one more thing to note, use parentheses for more than one polyatomic ion. So let me show you an example. Let's say I wanted you to write the formula for magnesium fluoride. Okay, so you would first find magnesium on the periodic table, Mg, and then you look at where it is and you're like, okay, it's in the alkaline earth metals. That gives it a 2 plus charge. And then you have fluoride, and you find that on the periodic table, and it's F, and it's a -1, okay? So what you're going to do is you want to find the simplest whole number ratio, okay? You have a +2 and you need to cancel out a -1. So you need another one of these -1s to cancel out your +2. So when you put those two together, you have 2 fluorines and 1 magnesium. So your formula is going to be this, MgF2. 2 fluorines, right? 2 of those fluorines and 1 magnesium. 2 pluses and 2 minuses gives you a overall 0 charge. Okay. Another example. What if I had sodium nitride? Okay. Sodium I find on the periodic table is Na plus, and nitride is N3 minus. Okay. Should be pretty obvious what you need here, right? You need another Na and another Na for a total of 3 to cancel out your -3. So you get Na3 and just 1 N. And we don't generally write ones, so you just write the letter. Okay, let's try out this one, aluminum oxide. Okay, this is one where I want to show you the charge flip trick because it works perfectly here. Okay, so you find aluminum on the periodic table and you say, okay, aluminum is Al3 plus, and oxide is oxygen, right? So oxide is O, and it's a -2 charge. Okay, and right now you're like, okay, a +3 and -2, I gotta think of common denominators, like, okay, Here's a super easy trick, and this works every time, and you can use it for all of these, okay? This is what I like to call the charge flip trick. The number from here becomes the little number down below here, okay? And the number here becomes the little number down here. So that means you end up AL gets the 2, and O ends up with a 3. See that Al2O3, and that is aluminum oxide. And that would be correct. We can go back and double check if you'd like. Al3 plus, and we said we're having 2 of them, so we'll go Al3 plus. And then we have oxygen, O2 minus, and we're going to use 3 of them, O2 minus, O2 minus. Okay, 3 plus 3 plus gives us 6 plus total. Great. 2 plus 2 plus 2 is 6 minus. Okay, so in total they cancel out. You can do this if you want, but it's not necessary. If you just want to do the charge flip trick, it works every time and you will be fine, okay? Whichever way makes more sense in your brain, that's what you should do. Go through and write the charges on there for each of the groups. If you don't have this done on yours already, just do it with me right now, okay? So group 1, these guys form +1 cations. Okay, and that's all of group 1. That's an arrow. This group is +2 cations. Okay, the transition metals, remember, you want to say cations, but use Roman numerals. Okay, these guys right here form +3. These are plus or minus 4. They don't really form ions, so don't worry about how you figure it out. These guys form minus 3. This is the -2. This group is -1. These guys, no ions. Okay, so it's super helpful. You should have that written on your periodic table, okay? So back here to a couple of examples, okay? If you're going to write the formula, you have first one here, lithium iodide. So you find lithium on the periodic table, okay? Lithium is Li plus. Iodide is I minus. +1, -1. Cancel out. So your formula is going to be Lii. You see, this is where those capital and lowercase letters are super important. Okay, calcium oxide. Calcium is Ca2 plus. Oxide is O2 minus. You can be pausing as we go here to find these yourself. Okay, 2 plus 2 minus, cancel out, right? And you always are going to write it in the lowest possible form, so CaO. If you do the charge flip trick, you'd get Ca2 and O2, but then you would simplify Ca, you wouldn't write Ca2O2, you'd just write CaO. Okay, next one, iron 3 chloride. Iron 3 is Fe3 plus, and chloride is Cl minus. It's a good time to do the charge flip trick. This 3 goes down here by chlorine. This is just a 1. We don't write 1s, right? So we just get FeCl3. Okay. And our next example is sodium nitrate. Sodium is Na with a +1. Nitrate, it's an 8. It's a polyatomic ion. It's on the back of your periodic table. Nitrate is NO3 minus. Notice the parentheses, okay? It's only a -1 charge, okay? So +1 -1 cancels. Your formula, NaNO3. The 3 has to be inside the parentheses. So that is a little bit about naming and formula writing. Yep, you guys are going to do some practice now. Enjoy.